Hello everyone, welcome back to IntelliSkills. In this video, we are going to be learning about the chapter Generative AI, which is requested video in our channel by our class 9 students. So finally here the video is. In this one short explanation video, you will understand all the topics that are there in your book about generative AI, and we'll have a detailed explanation about the concepts without overloading you. So let us begin. So first, let us understand what is generative AI. Just a brief about generative AI so that you get the starting for the chapter. Let us understand what is AI, like revisit. You already know what is AI if you have seen the previous videos. So AI means artificial intelligence, where machines try to act like humans. We humans think in a certain way, behave in a certain way, and mimicking that human intelligence. When machines mimic human intelligence, it's called artificial intelligence. Inside artificial intelligence, we have ML or machine learning. When machines are learning on their own from data by finding patterns explicitly without being programmed by any person. Okay, that means we the user give the machines the data, machine learns on its own from the data by finding patterns in the data, and then it can make the AI can actually make predictions. Okay, and we the users, we just provide the data to the machine, and after that, that's our job done right there. The machine finds out patterns on its own and learns on its own. We do not have to tell it how to learn. Okay, so that is machine learning. Inside machine learning, we have deep learning. Deep learning means like where you get all those neural networks. Like in our brain, we have the neural networks, thousands of neurons we have, which helps us to process information. And as AI is mimicking humans only, deep learning copies or takes inspiration from the human brain and its neural networks, and it creates an artificial neural network which is known as ANN. It looks like this. It has certain neurons. Got it? It has neurons which are in computer language known as perceptrons, and perceptrons are the smallest unit of a neural network. And inside the deep learning, we have Gen AI, generative. It's not like the conventional AI that we use, which does classification, clustering and all of that, but Gen AI is, or generative AI, generates new content. It can be text, it can be images, videos. Okay, like ChatGPT writes essays, that is using generative AI. Nowadays it creates images as well. Midjourney creates images, Gemini creates images. Okay, so those are using generative AI only. It can generate new content from a random data. It starts to generate. You have got a basic idea about generative AI. If you have a real image and a fake or AI generated image, how do you differentiate between a real and AI generated image nowadays? What do you mean by a real image? Actually, the image that you click using a camera. Now, it can be sometimes like, real images are usually like there's a consistent lighting throughout, but in AI generated images, there can be inconsistent lighting. There can be unnatural blurriness. Unnatural blurriness can be there as well. There can be sometimes repeating patterns. There can be abnormal shapes. And usually the prompts that people write to generate AI image, like a cat is dancing. So by that only you can understand in real world which cat dances like that. So a cat dancing, so you can tell that as a unrealistic situation, unrealistic elements. Like unrealistic elements, like certain people which are AI generated, they have 6 fingers, they have 3 hands, they have 1 more head, they have 3 eyes. So all of this are AI generated, and this happens due to a reason which we'll come to later when we'll be learning noise. Okay, why this unnecessary, unrealistic things happen. Now let us come to supervised learning. Now supervised learning, it uses labeled data. Suppose there is a email. Now what is a label? Label means every data will have its own tag or mark or label. Okay, that means this email, suppose we are segregating, we are training our AI model to separate spam emails into spam, to keep spam emails in the spam box and the non-spam emails in the inbox. So it needs to understand how to segregate between spam and not spam. So I'm adding a while training it, actually while training the model, what I'm doing is I'm giving it an email, sample email. I'm saying this is spam email, giving it a label. Okay, and another email I'm giving it. So here what is the data? They are the emails, and I'm giving this email certain labels, spam and not spam. So these are going to be labeled spam and not spam. Okay, this is why it is called label data. I'm giving thousands of emails like this, sample emails along with their labels. Now here in supervised learning, you see every input has its own output. Every input has its own output. Every email has its own label, spam or not spam. This is for supervised learning. Every input has its own output. In supervised learning, the model has to learn what? That for every input, if there is a specific output, that means if this email is marked as spam, that means there must be something written in this email which makes it spam. In this email, if it is not spam, there must be that particular thing absent, that particular language absent. That's why the model is that's why it is marked as not spam. That means it finds that in this email there is language like congratulations, you have won 1 crore. So that's why it is marked as spam. Informal language is used. In this email it's not used. That is why it is marked as not spam. So now it has found out the pattern, that this is why it is called spam, this is why it is called not spam. In supervised learning, the input is provided, the output is provided to that corresponding input, and it just needs to find the pattern, that why is this input having this output. Now it has found out the pattern, that if any informal language is used, we will call it spam email, else not spam email. Now when this was a training phase, now if any new email is given to it, for testing, it will analyze, is this having informal language, then it will say spam, and if there is no informal language, then it will say not spam. So each of these emails, they were having a label, spam, not spam, spam. Okay, so here we can say we had two classes. One is spam class, another is not spam class. Now let us learn about discriminative modeling. Now in discriminative modeling, if you provide it a particular data set, like this data set of thousands of emails with their labels spam and not spam, okay, if you provide it a data set of thousands of emails with the labels spam and not spam, here are two classes, which is spam and not spam. Discriminative modeling, it learns the decision boundary. Between the two classes. That means it learns the boundary between two classes. That means spam lies in this region, not spam lies in this region. Now the boundary between these two, by which you can tell that this is spam and this is not spam, that boundary discriminative modeling learns, and it can predict, if you give it an email, it can predict if it is spam or not spam. Okay, if you give it a combination of dogs and cats images, it can tell you which one is a cat and which one is a dog, because discriminative modeling, it learns that the decision boundary between a dog and a cat, these two are the classes, right? So it learns the decision boundary between dogs and between cats, and with that decision boundary, it can tell you which image is a cat and a dog. If the image has certain parameters which corresponds to this side of the boundary, it is going to be a dog. If the image has certain parameters which corresponds to this part of the boundary, then it's going to be cat. Okay, so I hope you understood what is supervised learning and discriminative modeling. In supervised learning, we used labeled data. In unsupervised learning, we use unlabeled data. In unsupervised learning, we use unlabeled data. That means the data here, it has only input, but it earlier in supervised learning, every input had its own output. Every email had its own label, spam or not spam. Here only input is there, no output. Okay, only a bunch of input is given, and then it needs to find patterns and it generates content like that. Okay, if you don't understand what I mean, I'm going to tell you. Suppose you give lot of images of cats to an unsupervised learning model, okay, which is unlabeled data. I am telling that it is an image of a cat, but the AI model does not know it is an image of a cat. I give it just images. I don't tell it if it is a cat or a dog or whatever. So I give it the images, and after that it finds patterns in the images, that every one of these, they have got whiskers, they have got a fluffy body, they have got furry texture, they have these kind of ears. So it notices these patterns, these hidden patterns. It finds out the hidden patterns. With this hidden patterns it has found. Now if you give it generative modeling, if you implement generative modeling, then it can produce more types of cat images with that hidden patterns. Now it knows that the animal has whiskers, it has this kind of ears, it has a fluffy body, it walks like this, it has short legs. With this information it can create new images. So here the use of generative modeling is done. Okay, and it is not necessary that generative modeling will use only unlabeled dataset. It can use labeled dataset as well, but mostly unlabeled dataset is used. Like a lot of road picture is given, okay, pictures of roads, and it is told to generate more road-like images, so it generates more road-like images. To generate an image, it needs a noise data set. So for generating an image, you need noise. Now what is noise? Noise can be of two types. It can be a bad noise or it can be a useful noise. Suppose your teacher is teaching something in class and some students are screaming at the back, some match is going on in the playground, that scream is there, so and the fan is making a continuous horrible noise, there's a creaking sound in the almirah. So all of this horrible things which are like your teacher is trying to impart a message to you, and that message, it is being disrupted by what? All these sounds, all these disturbances, right? It is interrupting the message from being received, right? So whatever that disturbs the actual message, that is known as a bad noise. Okay, that is the bad noise. So all those horrible sounds that was disrupting the information or the message conveyed by the teacher, that was bad noise. What is useful noise? This kind of useful noise is needed to generate images, okay, or to generate any content. Okay, so suppose you have a image of a human. Can you see the image of a human? A stick figure I have done, and slowly noise is added. Noise is added to the image of the human, and then more noise is added. Okay, the image becomes fully noisy. Like the shapes of the image, they start disappearing, they start nullifying, they start like becoming invisible. The image becomes extremely blurry and like pixelated. The image becomes horrible. Like first it was the image of a man, now it looks like the man has got chicken pox or something like that, smallpox. So the image becomes extremely blurry, the shapes of the image start disappearing. Okay, image becomes like this. So first to the AI model, first what happened is clear image was fed, right? The clear man's image was fed, and after that the image started becoming noisy. The image started becoming noisy. That means noise was added. Noise was added to the image. Actual noise equal to X. Suppose the actual noise added to the image, that is X. Okay, X amount of noise is actually added to the image. Now what the AI model will try to do? AI model will try to remove that noise. It will remove the noise by predicting noise value. Means using certain mathematical calculations, it will predict the value. Suppose it predicts a value which is x complement or x hash, whatever you call it. So now it compares it with the actual noise value. Actual noise that was added, it was x. It has predicted x hash. So if this predicted noise is not close to the actual noise that is added to the image, then it will again adjust and find the correct prediction of the noise. And like suppose it matches the actual noise added, which is a very rare case, but suppose it's very close to the actual noise which is added to the image. Now if it is close to the actual noise which is added to the image, then new image actual noise minus predicted noise, means the predicted noise will be subtracted from the actual noise. Okay, the predicted noise will be subtracted from the actual noise. Now some noise is removed, right? If you're subtracting the predicted noise from the actual noise, some noise is removed. Means what you're doing is basically x minus x hash or x complement. Some noise is removed from the image, so the image becomes somewhat clear, not fully clear but somewhat clear. Now after repeated subtractions, you will get this image back again. Though it might be still some noisy, but you get the actual image. So the AI model basically learned how to remove the noise. First it was given the clear image, then it became noisy. Noisy means basically you have seen that TV static, those black white things which start appearing, makes a horrible noise. So that is the noise, okay, which makes the image bloody, and it has to remove this noise. How? By predicting a noise value which is close to the actual noise added, and after that it is subtracted from the actual noise. The noise is reduced, and after repeated subtractions it becomes clear. Okay, this is noise. Basically there are some random data points just to begin the process of generating an image. Now as I told you, noise is a random data set of points, like rather random points or random data, okay, just to give a neutral starting to image generation. Like now if I tell you draw a cat, it's not like if I tell the AI model to create an image of a cat, it will copy from some database or it will copy from some Google image and it will give you that. No, it starts from a noise. Like if I tell you that draw a cat and I give you a blank white paper, you start scribbling, then you erase it, you start making a circle, that's the head of the cat. So your job started from random scribbles. If you just took an image of a cat and you start taking inspiration from there and you start drawing the cat, then that is not original. If you start on your own with scribbles only, then you will have uniqueness in your cat, right? So because of noise there is randomness, there is uniqueness. Like if you from someone's chat GPT, if you tell that generate an image of a cat, and if you ask it one more time, generate an image of a cat, 2 different times it will give 2 different outputs, because it starts from noise. So there is diversity, okay, there is free spirit of thinking, that I'm trying to tell. And when you actually scribble, you can give shape to this, so you can turn a chaotic thing into something meaningful. That is noise. You shape noise into, you make noise to something meaningful to generate an image. So first I showed you how to remove noise using that noise removal which the AI model did during training. Actually during training the AI model learns how to remove noise, so that while generating images it can remove the noise and it can transform it into something meaningful. Got it? Types of generative AI. First we have GAN, or generative adversarial networks. So this is the diagram of GAN, or generative adversarial networks. So there are two components here: generator, discriminator. Generator generates image, and discriminator, generator, so it generates fake image, right? It generates a fake image using noise, right? And discriminator tells if the image is fake or real. Okay, now if discriminator tells that the image is fake, that means discriminator is telling that generator, whatever image you have generated, that is fake. So generator needs to level up its game, and it needs to create more realistic looking images so that discriminator cannot tell that this is a fake image. Discriminator, when it tells that generator, this image is real, at that point of time, it is a win for generator, because generator actually, so it has created fake image, but if discriminator, it cannot discriminate between real and fake image, then that is a win for the generator. So basically a real image is provided to the discriminator, and whatever image generator generates, that is also provided to the discriminator. So discriminator has the real image, the generator's image. Now if it tells that the generator's image is fake, that means it is a win for discriminator and loss for generator, because generator has created such a poor image, such a fake looking image, that it could tell that it's fake, right? So it is a win for discriminator and loss for generator. So generator gains a loss, right? And discriminator, it does not gain a loss. Okay, discriminator, if it cannot recognize the generator's image and it tells it is real, then it is a win for the generator, because it created such a high quality realistic looking image that discriminator cannot tell that if it is real or fake. And loss, it is a loss for the discriminator, because discriminator could not discriminate between real and fake. So here in this case, discriminator gets a loss, but generator does not get a loss. Got it? There you can imagine generator as the chore, okay, or the thief, and discriminator as the police. Now the thief is stealing in every house. If it uses poor tactics to steal and all, then the police will easily catch. Police can easily catch the thief. But if the thief, it level up its tactics, and it uses like high quality tactics, then police cannot catch the thief. Similarly, if generator generates more realistic looking images, discriminator cannot catch. If it does not generate realistic looking images, discriminator can catch. Because of this, generator constantly creates more realistic looking images, and that is the advantage of GAN, because of the fear of the police or the fear of the discriminator, generator creates more realistic looking images. Again, discriminator tells that okay, this image is also looking fake. So again, generator needs to level up. So like this, generator becomes so good that at one time the discriminator cannot tell if the image is fake. Okay, this is RNN, or recurrent neural network. Okay, recurrent neural network. Now this is a typical neural network. It has this layer, which is the input layer, where all the input is passed. Then all the processing, it happens in the hidden layer. This is the hidden layer, and this is the output layer, where the output is given in the input. And these are neurons. Okay, these circles, these are neurons. Every neuron is interconnected with each other. This is a typical neural network, which is a feed forward neural network. That means it goes only in the forward direction. If you have a sentence, I am happy, and this is passed as in the input layer, then it is processed independently, am is processed independently, happy is processed independently. These three words have no link with each other, because in a typical neural network it does not preserve the word order. Or if you give an image or two images as input, then both of the images do not have any connection with each other, because in a typical neural network there is no memory. It doesn't have the recalling power. You can say that typical neural networks or a feed forward neural network, they go in the forward direction. They do not remember what happened previously, only what is forward. Okay, but in a RNN or recurrent neural network, there is recurrence. That means it can go forward, of course, but it can also go backward to the previous neuron to check, it has its own memory. That's why it can check what information it had previously and it can relate it with the next neuron's information. Okay, it always recurrents. Okay, and if you take this example, I am happy, then it will process I. At that time memory has nothing. It processes am and it recurrents to I. It checks on I. So in the memory it becomes I am, and then when it processes happy, in the memory it has I am and it recurrents to I am. So it becomes I am happy. So if everything has a connection, order is maintained. That is why recurrent neural network, it is used to process sequential data. So RNN, it is used in language translation as well, because suppose I am learning AI. If this, or I'm learning French, if this needs to be translated to some other language, say Bengali, then because it needs to preserve the word order, right? So it needs to visit the previous word and check its memory, right? It is also used in sentiment analysis. If you say I did not, it would struggle with a normal neural network, but in RNN it does not struggle, because it can go back to the previous information, which is a negative review, so it understands it's a negative review. It's used in sentiment analysis, then your language translation, all of this. Then also it is used in text prediction. Suppose you are writing how are, so that it predicts the next word, right, which is how are you. So it predicts the next word which is you. Based on what? Based on what we are writing. How are, you are writing how are, that is why it predicts you, right? So it recurrents to the previous words that you were writing. Based on that it predicted the new word. So where there RNN is used. So this is what a autoencoder looks like. There is the input layer where there is some input that is passed, and then there is the encoder part which encodes, means it extracts or it saves or it stores all the essential information only, all the essential important features of the input only, and it keeps it in the latent space, in the form of latent vectors. And then whatever the latent vectors from the derived from the encoder, whatever information of the input is contained, that is decoded, or that is reconstructed to produce the output, and the output is going to be very similar to the input. It's going to be very similar to the input. Did not understand? No problem. Let's take an example. Suppose there is in the input, I'm giving a picture of a cat, and my goal is to generate the same type of a cat. So I'm going to use an autoencoder. What I'm going to do is I'm going to pass an image of a cat in the input, and then the encoder is going to keep all the necessary information from the image only. Like when you click a picture of a cat, not all information is necessary, or not all the pixels are necessary in the image, because there is going to the background, some noise will be there, bad noise, background is there, some trees, some leaves, someone is screaming. So all the kind of these things, these are unimportant. These are going to be removed by the encoder, and hence it will be the information is going to be compressed, it's going to be shortened. You can see as it goes it becomes compressed, because the information becomes less, right? Because you only keep or preserve the essential information, like the whiskers, the ears of the cat, the fluffy texture of the cat. So only those pixels are kept. That is why it becomes compressed, and then it is stored in the latent space in the form of latent vectors. Okay, now in those latent vectors in which the essential information is stored, using that the decoder reconstructs the image using that information, and it gives you the output, and the output is going to be, that output cat is going to be very similar with the input cat. And if it is not similar, that means during reconstruction there was some error, which is known as the reconstruction error. The error produced during, because of which the output and input are not looking similar, that is the reconstruction error. This can come in your exam. And to reduce this who wants error? No one wants error in their life. So the decoder will adjust its weights, okay, to reduce the reconstruction error, so that the input and the output, they look similar. Now when is autoencoder useful? Like, you give it if you pass a very noisy image in the input, then it can keep all the essential information, it can reconstruct the image and give you a fresh, clean image of a cat instead of a noisy one. So you just converted a noisy image into a good image. That's where autoencoders can be helpful. Now suppose my requirement, as I told in the beginning, my requirement was I have a cat's image, I want to recreate that kind of a cat's image. But suppose I have a cat's image, I want to recreate different types of cats, not only the cat I was looking for in the input. Now autoencoder's problem is it cannot give you variation, it cannot give you different types of cats like I want. It can only give you the cat type of cat which was there in the input, but I want variation, I want difference. But autoencoders cannot give you that. Like, if you expand the latent space, if you basically expand the latent space, you will see there are various points here. So you will see in the latent space there are various points, a lot of points are there, and all the essential features of the cat, they are stored in the latent space in the form of latent vectors. That means in some latent points the information is stored. Suppose this point, this point, this point, this point, this point, and this point. In these few points which I have circled, in this the essential information which the encoder has compressed, that is stored, the essential information of the cat. Now the decoder, it takes only these circled points. The decoder, it takes only these circled points to reconstruct the image. Okay, the circle point means the vectors from the encoder. The decoder only takes the vectors from the encoder to reconstruct the image, because otherwise if it takes any other point, suppose it takes this bunch, okay, this middle bunch, then here most of the points, they are not circled, that means they are not from the encoder, that means information is not stored in these points. That means if the decoder uses this to reconstruct the image, then it's going to be garbage, because these points contain nothing but junk. Only the circled points, they contain the essential information, right? They contain nothing but junk. So the decoder cannot use this, but it has to use only these points. Now if it only uses this circled points, it will get the same output as the input. There is no variation. So to solve this latent space problem, there is another thing which is variational autoencoders, or the VAEs, variational autoencoders, which gives you variation. Everything is same, just the latent space representation is different. Okay, autoencoders, what you saw, only certain points were storing the information of the cat, but here after the encoder has compressed all the essential information, it is stored in a region and not certain scattered points anymore. Okay, it is stored in a region. Now if the decoder, it takes a sample from this region, it can reconstruct it into output which may be different from the input, but it is having variation. Okay, that is what I'm trying to say. This is the difference between VAE and AE. Okay, like if you imagine in this room, there are many chairs. Okay, there are many chairs. Now some people are sitting in stacks. Someone is sitting in this chair, someone is sitting at that corner chair, someone is sitting here, someone is sitting there. So they're all scattered. Now if I take a group of chairs from a certain region, it's mostly probable that it is going to be junk, because half of the chairs are empty, and whatever the chairs are having information, they are scattered here and there. If I pick a chair from a certain region, they are going to be junk. That is for autoencoder. But in variational autoencoder, the information is concentrated in a particular region. Okay, like instead of sitting on a chair, people are sitting on a sofa now. Okay, they are concentrated in a region, not scattered here and there. Okay, so if you pick certain people from the sofa region, nothing is going to be junk. Now if you see the difference between conventional AI and generative AI, conventional AI means the AI that we normally use, okay, and generative AI, they can be differentiated on the basis of their goal, training, data set and output. Based on their goal, how? Conventional AI's goal is to analyze, process and classify the images to improve its accuracy, its precision, recall, F1 score, all of this, to improve them. That is the goal of conventional AI, to classify, to cluster, like that. But for generative AI, the goal is to generate new content which looks realistic, or which is very close to the original content. Okay, that is the goal of generative AI. And next, in terms of training, now conventional AI is trained on the basis of supervised learning, unsupervised learning, then reinforcement learning. And generative AI, it is trained on the basis of GAN, which is generative adversarial networks, RNN, recurrent neural network. Then you have VAE, variational autoencoder, AE, which is autoencoder, it is trained using this. Then the data set, generative AI is trained on a large amount of data set. Obviously, if you give it unlabeled data, you need to give it in bunch, because the output is not known there. In conventional AI, comparatively, you need to give a smaller amount of data set, and the output in conventional AI, you still know that this is the input, so this can be the most probable output. But in generative AI, you do not know what kind of output will produce. It's going to be new every time, because it's generated from noise. Oh, and by noise, you know, I told you that in noise, you have to predict the noise, then you have to subtract the noise from your actual noise, right? Now, always the prediction isn't true, right? Always the prediction is true. Prediction can be true always, never. So there is a prediction error that happens there, prediction error. And over time, the prediction errors get accumulated. And that is why, because of this error, one more finger, one more hand, 3 eyes, all this happen. Okay, so this is the difference between conventional and generative AI. So now we are going to study about benefits of generative AI. First, we have creativity. Creativity in the sense, like whenever we tell the generative AI model to generate any image for us, suppose it starts with a noise, or any content, it starts with a noise, and due to that noise there is variation in the image, because from every noise it will modify, a new image is going to be created, right? Every time something new will happen. If you ask ChatGPT to write an essay for you, it will not give you the same essay every time, even if you give the same topic. So there is creativity. Next point is efficiency. That means all these generative AI models, they are more efficient. They help us to save time, because if you write an essay manually, it will take a lot of time, whereas if you tell any AI model to write an essay for you, they will do it in seconds. So it reduces a lot of manual effort. What work is being done manually, it does it in a fraction of seconds. Next point is personalization. That means it creates personalized content for everyone. Like based on your likes, your dislikes, your behavior, how you want your content to be curated. Based on that, it personalizes that content for you. Like if you want certain specifications in your essay, this points you really want, or this is how you want it to be written. If you want it to be written in simple language, it will personalize and curate it in a simple language just for you. And if you want it to be written in a rich vocabulary, Shashi Tharoor types, then it will do that also for you. Next point is exploration. Now when you dive into AI, it always gives you new ideas and things with which you can experiment, right? So it opens up a new world of experimentation for you. Like scientists using AI, they have discovered a new drug molecules, right? And also it opens up a huge scope of research for you. So this is how you can find benefit using exploration. Next is accessibility. That means generative AI is accessible to everyone, or they do not have the tools. It helps them, it's very accessible. Like people with hearing disabilities, for them there is it is written in text form. The people who cannot see, for them there is like text to speech, speech to text. All of these features are there which make it accessible. Then there is scalability. Okay, it can work tirelessly 24/7, generating content for a large number of people. All right, like all the big businesses and organizations where large amount of data is needed, heaps of data are needed, there this feature is very useful, because all those large number of data, they are computed very easily, and it can generate content for large number of people as well. This helps in big businesses and corporations and all. Now we come to limitations of generative AI. First is data bias. Okay, data bias. Now, when does AI become biased? See, whatever the training data with which you train your AI model, based on that only it will predict and all. I mean, if the training data is biased or it is not fair, it contains any misleading information, AI is going to learn that. Right, yeah, the AI model is going to learn that misleading information, that bias only, and whatever output or prediction it will make, that will be biased only. So this is why it is very important that we feed the AI model the right kind of training data, the valid, the ethical training data we feed it. That is very essential. Now comes the second point, which is uncertainty. That means it's not always certain that the AI model, whatever prediction it will make, that will be always true or accurate, because it predicts the most probable answer, not the most true or correct answer. Okay, always the probable answer. So it can be incomplete information, it can be incorrect information or fabricated information. Okay, that is why AI models, generative AI models, are very uncertain sometimes. Full confidence it's giving incorrect output, that happens sometimes. So that is uncertainty. Next we come to computational demands. Now everyone wants that their response will be generated in a fraction of a second. For that, there is a huge processing power. Many GPUs and TPUs are needed to build large models, right? Which is obviously it's very costly. And to train the model, again, there is it can take months and months, even years sometimes. It's very costly, and also it's very time consuming, right? Now we are going to study about the ethical considerations of using Gen Z AI, generative AI. So first there is ownership. Suppose AI model has generated a song. Now will the AI model be considered the real owner of the song? No, because the AI model is trained by someone. So the person who has put the training data, that person should be considered the real owner of that song which is generated, right? So you cannot say that you have just given the prompt that do this song for me or something like that. You are not the owner. AI model is not the owner. Who is the owner? The person who has fed the training data. Based on that only AI is giving the response. Now, why is this an ethical issue? Because it creates problems or conflicts related to copyright, fair use and all. Okay. Next point is human agency. Now, humans nowadays, they have become too much dependent on AI, especially generative AI, to generate all of their content, essays, homework, code, whatnot, music, everything basically. So their creativity power has decreased significantly, and in future it will decrease more. Next point, bias. I already told about bias. If the training data contains any stereotypical things, or there is bias there is unfair things there, or misleading information there, that will be replicated in the output of that the AI model will give. Okay, there will be some patterns of unfairness that you will see. So there is high chances of bias. Next is misinformation. Using AI, we can create fake realistic looking images, videos, and we can people can spread misinformation with this. Okay, nowadays people are creating deep fakes, which are unethical images. So there we can see misinformation being communicated through AI. Next is privacy. If the AI is trained with any sensitive data, or if users give too much of their personal information to the AI, there's high chances that the AI will misuse the information, or it can hamper the privacy of the user, right? Now we'll study about negative impact of generative AI on the society. First is spread of misinformation and fake news. So fake news, talking about fake news, AI can generate realistic looking fake things, fake news, and this reduces the trust of common people on the media and the news channels, right? And also coming to the concept of deep fakes. Deep fakes are fake videos or audios. Suppose a person did not say something, the AI has curated that voice recording in that person's voice, and everyone is assuming on the internet that the person has said it. So it can be used to generate a lot of misleading videos and audios, right, which can damage a person's reputation. Now coming to lead to job displacement. Now there comes the concept of automation, because earlier what used to happen is the process of creating, designing, executing, everything was done by humans, but nowadays everything is done by AI. So the position of those humans are being replaced by the AI, and because of the automation, everything is being automated right now. That is why it leads to job displacement. And also it causes economic disturbance, because now many people, because of AI, especially in the IT sector, there is crisis of jobs, because AI has come, it's replacing everyone, so more unemployment is seen. Now coming to the concept of privacy risks, there comes the word data breaches. Okay, now when the personal information is given to the AI, sensitive information is given to the AI, hackers, what they can do is they can extract that sensitive and private information of a user, and therefore that can be used in misleading purposes. It can damage the reputation of a person, or lead to financial or emotional damage. Now coming to ethical and moral concerns, there is bias and discrimination. I've already explained a lot of times. And now comes the concept of dehumanization. That means AI, over reliance on AI, it causes humans to become less human-like, because in certain sectors empathy and compassion are needed for humans, but over reliance on AI cannot provide that, right? That is why there is that space in humans for emotional longing, which causes dehumanization, becoming less human-like. Now security threats. Now using AI, one can do cyber attacks, because using AI one can create extravagant hacking systems. There is also weaponization. Using AI one can create dangerous weapons, which is a threat to the nation and globally it is also a threat, and national wise it is also a threat. Okay, now environmental impact, as I already told you, huge computation is required, much power is required, many TPUs and GPUs are used, high power is used, which increases the carbon footprint and contributes to global warming at one point, which is harmful for the environment. And then comes the concept of increase in e-waste, which is electronic waste. All this hardware that you see, all these chips and all of those, they are electronic waste, and manufacturing requires a lot of electronic things, which again get dumped, causes increase in the e-waste. Now again, one last thing is left, I'll just cover that: responsible use of generative AI. So one should, as there is a risk of the AI getting biased and spreading misinformation, there should be technologies to detect those biases and misinformation, and also data should be used which is totally clean and not filled with any kind of unfairness or bias. Otherwise the machine is going to learn that data only, which is in fact going to be biased. Okay, privacy of people should be prioritized. Private information can be misused, right? So data encryption and data anonymization should happen properly. So these are the things, and if you have listened to my words properly, I'm guaranteeing you can frame your own answers in exam. Okay, that was it for this video. I'll meet you in the next video. Till then, keep learning, keep practicing, and keep exploring. Thank you, and bye bye.